Section 1.5. This is the definition of a midpoint. A midpoint is a point or ray segment or line that divides a segment into two congruent segments, bisects a segment. The bisection part is called the midpoint of the segment. So here, point X is not the midpoint, and point Y is also not the midpoint. Here's our first example. If line XY bisects line AC at point B, what conclusions can we draw? So from this diagram over here, we can conclude that point B is the midpoint of line AC because line XY bisects AC. So because it's bisecting, the point it bisects at is the midpoint, which is point B. We can also conclude that line AB is congruent to line BC. Yeah. Trisection points and trisecting a segment. A segment divided into three congruent parts is said to be trisected. So when it's trisected, it's divided into three parts instead of when it's bisected, which is when it's divided into two parts. The definition of a trisection point is two points or segment rays or lines that divide a segment into three congruent segments. Trisect the segment. The 2 points at which the segment is divided are called the trisection points of the segment. Here's our first example. If line AR is congruent to line RS and is congruent to line SC, what conclusions can we draw? Well, we can actually conclude that R and S are the trisection points of line AC. We can also conclude that line AC is trisected by R and S. That's restating the first conclusion. Angle bisectors. Like an angle like a segment can be bisected. A ray that divides an angle into two congruent angles bisects the angle. The dividing ray is called the bisector of the angle. If angle ABD is congruent to angle DBC, then ray BD is the bisector of angle ABC. As you can see, ray BD bisects angle ABC because it goes through the middle of it and divides it into two congruent angles. Angle ABD and angle DBC. Angle trisectors. Two rays can divide an angle into three equal parts. The definition of an angle trisector is two rays that divide an angle into three congruent angles trisect the angle. The two dividing rays are called the trisectors. If angle ABC is congruent to angle CBD and is congruent to angle DBE, then ray BC and ray BD trisect angle ABE. So as you can see, we have ray BC and ray BD, which are depicted in black, trisecting angle ABE because they go through the middle and split it up into three congruent angles. First, we have congruent angle ABC, then CBD, and then DBE, which are all congruent. Problem 1. The tick marks indicate that line RS is congruent to line ST. Is S the midpoint of line RT? As we learned in previous sections, these three lines are actually not collinear. Therefore, point S cannot be the midpoint because they don't lie in a straight line. So the answer would be no. The points are not collinear. So S cannot be the midpoint. Problem 2. If BD bisects angle ABC, does ray DB bisect line angle ADC? And the answer is no. We need more information because it never actually tells us that any of these angles that we are bisecting are congruent. Therefore, we cannot conclude that ray DB bisects the angle. Problem 3. If B and C trisect line ray AD, do ray EB and ray EC trisect angle AED? The answer would be no. It's not true that line AB is congruent to line BC and is congruent to line CD. But the fact that the segment has been trisected does not mean that the angle is trisected. So we know that B and C trisect line AD, but from this we can't conclude that ray EB and ray EC trisect angle AED. so we cannot make conclusions here. Problem 4. Given the given statement is that ray PS bisects angle RPO. And here we have to prove that angle RPS is congruent to angle OPS. So here we have to use a 2-column proof, which has one side which is the statement and one side is the reason. So the statement would be that angle ray PS bisects angle RPO. This, and the reason would be it's given, because as you can see, this is given to us. And the second statement, our final statement, would be that angle RPS is congruent to angle OPS. So here's a visual. Angle RPS is congruent to angle OPS. And our reason for this is that if a ray bisects an angle, then it divides the angle into 2 congruent angles. As you can see in this diagram up here, we have angle RPS and angle OPS. And ray PS bisects them here, as you can clearly see, which means that they are congruent to each other. Thank you.
Section 1.6. The objective of this section is that we will learn to write paragraph proofs. Part 1, Introduction. We need to be familiar with 2-column proofs and paragraph proofs. Paragraph proofs are important because paragraph proofs are used in journals, more advanced mathematics courses, and other areas of study. The simple problems will show how to write paragraph proofs and how that they can show that a conclusion can be proved true or not true. We're given that angle 1 and angle 2 is acute. The conclusion is that they are congruent. Our paragraph proof states that this conclusion cannot be proved. For example, if angle 1 is equal to 20 and angle 2 is equal to 30, they are both acute, but they are not congruent to each other. An example of this is called a counterexample. Problem 2. We are given the diagram shown. We need to prove that angle DBC is congruent to angle E. According to the diagram, angle ABC is a straight angle, which means 2x plus x equals 180, 3x equals 180, which means x equals 60. Since angle DBC is equal to 60 and angle E is equal to 60, that means they're congruent. Problem 2. We are given the diagram shown. We need to prove that angle FEH is congruent to angle JKM. We can start by doing this by setting them equal to each other. So 135 equals 3x. Then we solve for x, which means x is 45. When we plug in 45, we get 135. We are given that angle 1 is obtuse and the angle 2 is acute. We need to prove that they are congruent. Since we don't know the exact measures, we cannot prove that they are congruent.